Welcome to Understanding Edge Computing. Edge computing is a technology that brings data processing closer to where the data is actually created, instead of sending everything to distant cloud servers. In this video, we'll explore what edge computing means, how it works, and why it's becoming so important in our connected world. The subtitle here is Processing Data Near the Source, which is the core idea behind edge computing. By processing information locally, we can make things faster, more secure, and more efficient. Edge computing uses a three-layer architecture that works together to process data efficiently. At the top, we have the cloud layer, which is the centralized data center in the internet. It stores large amounts of data and performs complex analysis. In the middle is the edge layer, which includes local servers and devices positioned close to where data is generated. This is where most of the real-time processing happens. At the bottom, we have the device layer, which consists of sensors, cameras, and Internet of Things devices that collect the raw data. Data flows from devices to edge servers for immediate processing, and only important information gets sent to the cloud for long-term storage and advanced analysis. There are four main reasons why edge computing is valuable. First, reduced latency. When you process data locally at the edge, you eliminate delays. Responses happen almost instantly instead of waiting for data to travel to a distant server and back. This is critical for applications that need immediate decisions. Second, enhanced security. By keeping sensitive data closer to its source, you reduce the risk of it being intercepted during transmission. Third, real-time analytics. Edge computing allows instant insights without cloud delays, enabling immediate decision-making. Finally, lower costs. You reduce bandwidth usage by processing data locally instead of sending everything to the cloud, and this saves money on cloud computing expenses and network transmission. Edge computing is already transforming several industries. In autonomous vehicles, ultra-low latency communication is critical. Self-driving cars must process sensor data and make decisions in milliseconds without waiting for cloud responses. In healthcare, patient monitoring devices can analyze vital signs in real time directly at the hospital or clinic rather than sending all data to a central location. Manufacturing facilities use edge computing for predictive maintenance, analyzing equipment health right on the factory floor to prevent breakdowns before they happen. Cloud gaming works better with edge processing, reducing the lag between your controller and what you see on screen. Smart homes benefit from local processing, so your lights and temperature systems respond instantly to your commands. And smart grid systems use edge computing to optimize energy consumption and manage power distribution efficiently. Despite its benefits, edge computing faces four major challenges. First, security complexity. A distributed system with many edge devices creates more entry points for attackers, making security management more complicated. Second, management overhead. It's difficult to monitor, update, and maintain software across hundreds or thousands of distributed devices. Third, storage constraints. Edge devices have limited hardware capacity, so they can only process and store a certain amount of data locally. Finally, network reliability issues. Edge devices might experience intermittent connectivity or bandwidth limitations, especially in remote locations. These challenges require careful planning and robust solutions when implementing edge computing systems. Edge computing is evolving rapidly in several exciting directions. First, edge artificial intelligence integration. Machine learning algorithms are being embedded directly into edge devices, allowing them to make intelligent decisions locally without sending data to the cloud. Second, 5G adoption is accelerating edge computing deployment. 5G networks provide ultra-low latency and high bandwidth, making edge applications faster and more reliable. Third, containerization is becoming standard, with technologies like Docker making it easier to deploy and scale applications across edge infrastructure. Fourth, decentralized applications using blockchain are running on edge networks for distributed and secure processing. Fifth, zero-trust security protocols ensure that every access request is verified, adding protection to distributed systems. Finally, 6G is in development, promising even more advanced capabilities for edge computing and beyond. Let's compare edge computing with cloud computing to understand when to use each approach. Processing location differs. Edge computing processes data at the source or locally, while cloud computing processes everything in centralized data centers. Latency varies significantly. Edge computing delivers ultra-low latency, measured in milliseconds, because data barely travels. Cloud computing has higher latency because information must travel to distant servers and back. Bandwidth usage is dramatically different. Edge computing reduces bandwidth by processing data locally and sending only essential information to the cloud. Cloud computing requires sending all data to centralized servers, using much more bandwidth. Scalability works differently too. Edge computing is limited by local resources available at each location. Cloud computing offers virtually unlimited scalability since you can add more resources to centralized data centers. In practice, many organizations use both technologies together, leveraging edge computing for quick local decisions and the cloud for large-scale storage and complex analysis. Edge computing is transforming multiple industries with practical applications. In automotive and transportation, we have autonomous vehicle decision-making happening in real time, fleet monitoring systems tracking vehicles, and driver safety detection systems that respond instantly to threats. In healthcare and medical applications, we see patient vital signs being monitored continuously, medical imaging being analyzed on-site, and emergency response systems that act immediately. Manufacturing and industry use edge computing for predictive equipment maintenance that prevents costly breakdowns, quality control inspection that happens instantly, and production optimization that improves efficiency. In retail and commerce, inventory management systems track stock in real time, cashierless checkout solutions operate without manual cashiers, and customer behavior analytics help improve store layouts and product placement. These applications demonstrate how edge computing delivers real value across diverse sectors. To summarize, edge computing brings computational power closer to data sources, enabling faster response times, reduced costs, and enhanced security across industries. Here are the key points to remember. First, lower latency means real-time processing without cloud delays. Decisions happen instantly when data is processed locally. Second, bandwidth efficiency reduces data transmission to centralized servers. By processing locally, you send only essential information, saving network resources. Third, distributed intelligence means autonomous processing at data sources. Each edge device can make decisions independently without relying on central servers. Finally, edge computing creates the foundation for future technologies. It supports artificial intelligence applications, 5G networks, and emerging technologies that will shape our connected future. Edge computing represents a fundamental shift in how we process and analyze data, moving away from centralized approaches toward distributed, responsive systems that work where the action is.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.